Bismillahirrahmanirrahim. Assalamu alaikum viewers. In this video we will discuss about acid base indicators. Basically there are four types of titrations: acid base titrations, complexiometric titrations, redox titrations and precipitation titrations, and in which one type acid base titrations. In these indicators are used. Today we will discuss about these indicators, acid base indicators. Firstly, have a look on acid-base titration. In acid-base titration, the base solution can be added gradually from a burette into an acid solution contained in a receiver flask. When the amount of base added equals the amount of the acid in the flask, then equivalence point or the end point is reached. Means this equivalence point shows the equal amount of base added in the acid. Okay. What is the importance of acid base indicator? Basically, this equivalence or end point is indicated by the indicator. Acid base indicator is basically an organic dye that signals the end point by a visual change in color. There are two common examples of acid base indicators: phenolphthalein and methyl orange. Phenolphthalein is basically pink in base solution and it is colorless in acidic solution, and after that methyl orange, it gives the red color in acid and gives the yellow color in base solution. Here are a few examples of acid base indicators like methyl orange, methyl red, litmus, bromo thymol blue and phenolphthalein. Here their color change. Acid base means what is their color in acidic media and what is their color in basic media. After that there is pH range. Have a look on phenolphthalein. It is colorless in acidic solution and it is in pink in base solution. After that its pH range is from 8.3 to 10. After that, pH curves and indicator range. Basically, during the acid base titration, with the addition of titrant from the burette, the pH of the solution in the receiver flask changes. And when we plot the graph pH against the volume of the solution being added, then this curve is basically known as pH curve or titration curve. Now have a look on this graph. This graph is showing a curve. Here basically this is starting and here it is basically horizontal and it shows the volume of the acid added, and it's vertical which is showing the pH. When at the start there is addition of base from the burette into the acid, then it's the change in pH of acid is slowly, and here it slowly increases. After that there is rapid increase and it shows the here a vertical portion of that curve, and at the mid there is equivalence point, means equivalence point where the base which is adding in the acid becomes equal, means here the indicator shows the change in color. After that it gradually slowly. That's basically the curve or pH curve. After that, suitable indicator. A suitable indicator for a given titration, it may be defined as a one which has a narrow range of pH as possible, that lies entirely on the upright part of the titration curve, means it lies here on the upright part of the titration curve. Here this is upright part. After that, choice of a suitable indicator. On the basis of nature of acid and base, the acid base titrations have four categories: a strong acid with a strong base, a weak acid with a strong base, a strong acid with a weak base and a weak acid with a weak base. Let's discuss about these types. And the first one is titrating a strong acid with a strong base. In it, the strong acid is sodium hydroxide and the strong base is HCl solution. Let's have a look on the titration curve. Here, this is basically the titration curve for the acid-base titration, in which the acid and base both are strong. The volume of NaOH, and here on the x-axis, after that there is on the y-axis pH. At the beginning, the pH rises slowly, but after that it dramatically increases, and it's a vertical portion of the curve. And after that the pH rises, and this pH rises is only when the amount of base added exceeds. And here have a look on pH range. The vertical portion, which shows the equivalence point, is having range from 3 to 7, and the indicators methyl orange and phenolphthalein, these both lies in the range of our strong acid and strong base titration curve. So phenolphthalein and methyl orange both are suitable for strong acid and strong base titration. After that, weak acid and with a strong base. Weak acid is basically acetic acid and strong base is sodium hydroxide. Let's have a look on its titration curve. Here the volume of NaOH on x-axis and pH range on y-axis, and the curve for the weak acid and the strong base is similar to the strong acid and strong base curve. But here at the beginning there is a gradual or very slowly rises the pH. After that it's near the equilibrium. Here near the equilibrium it increases, abruptly increase from 6 to 11 at the equilibrium, and after that this is again slowly becomes, this shows basically the increase of base. Volume of NaOH increases, then this slowly becomes right here. After that the pH, the main point in this weak acid and the strong base is that the pH ranges, as it's the titration curve for it is from 6 to 11, and methyl orange range is not on the vertical equivalence point. So the methyl orange, its pH is from 3.2 to 4.4, and phenolphthalein is from 8.2 to 10. So methyl orange is not suitable for the this weak acid and strong base titration. Only the phenolphthalein is a suitable indicator for it. After that, there is titrating with a strong acid with a weak base. Strong acid is HCl and weak base is ammonium hydroxide. Let's have a look on its curve. After that, there is basically the curve. Volume of ammonium hydroxide, it's basically after that here a pH range. At the beginning there is a gradual change, slowly, but after that there is abrupt change, and here a vertical portion shows the equivalence point, and its range is from 3 to 8, where it shows the sharp change in pH. And the methyl orange range is from 3.1 to 4.4, and The methyl red ranges from 4.4 to 6.0. That falls on the vertical portion of the titration curve. But the phenolphthalein doesn't lies in its vertical portion. So it's not suitable indicator for the acid base titration in which the acid is strong and weak base is used. After that, there is titrating with acid and base weak. Weak acid is acetic acid and weak base is ammonium hydroxide. Let's have a look on its titration curve. And at the beginning there is a gradual slowly change, but in it there is no sharp change in pH and vertical portion is missing, and there is no vertical portion means no equivalence point for it, and there is no range in which the indicator lies. So there is no suitable indicator for the acid base titration in which both are weak. These are basically the types on the basis of nature of acid and base. Thanks for watching.